Okay, ladies and gentlemen, welcome to the second video for the Section 6, Chapter 2 notes. So 2-6 notes for geometry. This video should be relatively short. It's going to show an example of an algebraic proof, going through how formal that process is, and it will show the non-proof examples from this section as well. There will then be 2 additional videos that show some of the problems from your algebraic proof classwork so that we have additional examples of algebraic proof. So here is an algebraic proof. We are told to prove that if -5 times the quantity x plus 4 equals 70, then x is equal to -18. And notice it says we have to write a justification for each step. So in other words, we are being given that this is a true statement. -5 times the quantity x plus 4 equals 70. We are being asked to prove that x is equal to -18. So we're going to write out a formal geometric proof of this algebraic statement. It's called an algebraic proof. Now, you may look at that equation as someone who has some experience with solving equations and say, it doesn't seem like that should take 7 steps. Well, in algebra, it doesn't. But in geometry, it does. Because one of the things about a geometric proof is that they are extremely formal. And we have to show every single step of work and explain why it is legal every single step of the way. So every geometric proof, whether it's an algebraic proof or a geometry-based proof, starts exactly the same way. And that is by relisting the given information. So your first statement in your proof should read the same as the given. -5 times the quantity x plus 4 is equal to 70. This is given. That is the reason as to why we know that it is true, because given information is always true. No matter what geometric proof we solve, our first step is always to relist the given information. So then, as a student that has taken some form of algebra or has this year learned how to solve algebraic equations such as this one, you should recognize that your first step in algebra is to distribute. So we are going to use the distributive property in step 2. However, in geometry, we have to show it in one step and then simplify it. What I mean by that is we actually show that we're doing -5 times x and -5 times 4. We have to write that step out. First we have to show it, which is the step that gets labeled with the distributive property. And then we are actually going to simplify that step, which would be -5x minus 20 equals 70. And any time that we simplify, we are going to use the substitution property, only we are going to list it as substitution parentheses simplify, because there is another way that we will use the substitution property in later proofs that will be a completely different use of that property. So we are using the substitution property any time that we simplify. Now, as a student that has taken this course or has been in an algebra class before this, because some of you are upperclassmen, you should know that the next step in solving this linear equation here in step 3 is that we should be adding 20 to each side. So we have to show that by saying -5x minus 20 plus 20 equals 70. I'm not sure I got the color changed. I did not. Equals 70 plus 20. So we actually physically show the adding of 20 to each side of the equation. That step is labeled the addition property of equality because we are adding 20 to each side. First we show it, then we actually carry out the addition, which causes the 20s on the left to cancel. 70 plus 20 is 90. And again, anytime we simplify, that step is justified using the substitution property, with us noting that we are using it to simplify. The next step in the process of solving this equation would be to divide. So we're going to divide both sides of our equation, if I can get my pen to behave. Stop it, pen. don't have time for this. There we go. To divide each side of this equation by -5. So once again, we show that first. We show -5x divided by 5 equals 90 divided by 5. That step gets labeled with the division property of equality. And again, I'm not making you write out of equality, but all of these properties are equality properties. And then we actually divide, which would leave us with x equals -18, substitution property being used to simplify. Now please notice that the final statement, statement 7, is exactly what we were being asked to prove, x equals -18, which means that we have successfully completed this proof. So a couple things to note. One, every single time that you multiply, divide, add, subtract, or distribute, that is a two-step process. Because the first step, such as in 2 or 4 or 6, we have to show that happening. So here we're showing distribution, here we're showing addition, here we're showing division. And then in the next step, we simplify it. So it's always show it, then simplify it. Show it, then simplify it. Okay? That is an algebraic proof. Now let's look at the non-algebraic examples. So the other thing in this section is identifying these properties in practice. Okay, so here are 3 examples of that. It says state the property that justifies each statement. So what we have to do is use our list of 9 properties, the addition, subtraction, multiplication, division, reflexive, symmetric, transitive, distributive, or substitution properties to identify what is happening between the hypothesis and conclusion of each of these statements. So in statement 1, you should notice that basically what we're looking at there, it says if A equals B, then B equals A. That is the symmetric property of equality. We are switching the left and the right sides of the equation. Okay, in number 2, we have to ask ourselves what is happening to x equals 4 to turn it into 2x equals 8. And what's happening is we're multiplying both sides by 2. That gives us our 2x equals 8, which means that this is the multiplication property. Okay, finally, in the last step, we should recognize this one pretty quickly. That is distributing. That's what's happening there. We're doing 8 times x, 8 times 4. So that is the distributive property. Okay, so you're going to have a homework assignment in this section and a classwork assignment. The homework assignment will involve the postulates that you learned in section 2.5. Doing some work with deciding whether or not some statements are always, sometimes, or never true based on those postulates. And then a backside of that page will have a whole bunch of these problems on it. That is going to be a homework assignment. And then you'll have some algebraic proofs as a classwork assignment, and you'll be given classwork time to do that. So thank you very much for your attention. There will be 2 additional videos, although they will not be up as quickly as these will. That will show some of the problems from the classwork assignment, because we're going to do some of them together in class. Those videos will be up eventually, but these are going to go up immediately for those of you that are stuck at home having to listen to me on video. Thank you very much for your time. I appreciate you. Please keep working hard.